welcome to the 2021 Trends in Data, Machine Learning, and AI. I'm here with Mikio Braun, my co-conspirator on this podcast, and Jenn Webb, who is going to moderate this particular episode. So I'll turn it over to our editor, Jenn Webb.
Thank you, Ben, and thank you, Mikio, for joining us today.
Yeah, you're welcome.
So last year, you two made some predictions around, I'm just going to cover the broad areas. If listeners would like to take a deeper dive to see what you predicted and judge you on it, they can go to the dataexchange.media and look at episode 4 of the Data Exchange. But your predictions mostly covered things around reinforcement learning models, deep learning models, emerging use cases for certain types of applications, covered some infrastructure and tool topics, risks, and fun emerging technologies, which we'll get to for this year too. But taking a moment to look back at last year's predictions, what would you say was maybe the biggest miss? And if you want to start, Mikio?
Yeah, I mean, so we all know how 2020 turned out, right? So I'm actually quite surprised we got some of it right. I think one topic that I still remember is we talked a little bit about these like GPT-3, the new models and the upcoming election, right? And whether that would play a role. But I think in the end, it turned out that you don't need any of that at all. So you can just use like much simpler methods. So you don't need all that AI because I think we've seen a lot of like questionable activities there, but they didn't actually evolve any AI.
Ben, what do you think?
Yeah, I think so. I think maybe I was a bit too gung-ho about reinforcement learning, which I think is playing out, but not maybe in the velocity that I thought it would. I mean, I think it's still mostly a province of machine learning experts and researchers. The tools are starting to get better, but I don't think we have quite the tutorials and the material we need to really put this in the hands of developers. So there's that. And then I think there's some kind of more boring technologies that we probably should have talked more about, which we'll talk about for 2021. But I think actually there's quite a bit of, there was more activity in data engineering than we mentioned last year.
Okay. And so taking a look at some of the predictions you made that did come to pass, what are some practical ways, what were those things, and what are some practical ways that they affected you in your work or in your processes or your approaches?
Oh, so I mean, I think for me, so when it comes to end-to-end machine learning platforms and importance of distributed learning, I think those are kind of playing out for me in terms of just more emphasis on tools like Ray, which make reinforcement learning transparent and by default. And then the importance of so maybe the machine learning is not quite end to end in day to day, because there's still a lot of things that you have to manually take care of, but there are big pieces of machine learning which now seem a little more automated. Like I don't know how you feel about it, Mikio, but experiment tracking tools seem to have gotten better. Not just MLflow, but weights and biases and other similar tools. So it is probably still the case that there's still a lot of care and manual process involved when you get to the deploying machine learning.
Yeah. Yeah, I think overall we weren't wrong. We were just too enthusiastic, too optimistic that these would actually be solved in 2020, right? So you mentioned MLflow, which I think is still picking up, but then, yeah. So it's not like that was actually solved this year, or maybe will not even be solved next year. So it's like an ongoing challenge, I would say.
And then in terms of distributed computing, I mean, I think the main area that I notice more and more activity, obviously, is distributed training, because the deep learning models are getting bigger, and the tools for distributed training continue to improve in 2020. I think
Yes.
Horovod has gotten better. Now Horovod is integrating with Ray. A bunch of natural language processing libraries have now Ray integration, including Hugging Face and Spacey, so you can scale out. So generally, I think we're at the point where there was improvement in terms of distributed applications of distributed computing to day-to-day tasks, but not at the point where it's something that every data scientist can quickly use.
Yes. Yeah.
So
And
no, go ahead.
Yeah, and there was still so NVIDIA was still sort of putting one more in there with the new RTX like 3000 series. So that was like I remember, right? So it was a huge run. You couldn't get these. They were sold out in, I don't know, minutes or something. So there's still like an ongoing demand for more GPU computing power. I think it's also interesting because there was already it feels like there was already like a lot of like really expensive, huge GPUs that people were using, but apparently there's still need for even bigger and faster hardware. Yeah.
And so just two more questions on the 2020 thing. One, what would you say is the most significant development from 2020, and or if anything surprised you, something unexpected? And Mikio, if you want to start.
Yeah. Yeah, I think actually what I think surprised me, or what was a bit unexpected, was that so I think there's also now predictions for it. I don't want to spoil it, but so it's coming full circle now. It becomes even more commoditized, and especially sort of deep learning, but for prediction, that seems to make a huge push. So we just had the Apple M1 processor, who came with integrated sort of neural compute units, which are more optimized toward applying machine learning models. So not training, but let's say you have some speech model or so that you could use it actually without, like more like a low power and implementation of that. And that means, right, everybody's getting ready to really make super widespread use of AI technology. I think that was really surprising. So because it's also something new, right? It's not just more and more compute power, but it's actually like a new kind of capability that everybody will have in their devices at some point.
Ben?
I think for me, how quickly people started using some of the language models that they read about. I think part of it is just because now there seems to be a more faster turnaround between research and then being incorporated into an open source machine learning library that developers use. So for example, many of these language models that come out in research then get implemented in tools like Hugging Face, Spacey, Spark NLP, and so developers can take advantage of them. I think if you were to look at the computer vision in the early days of deep learning, so well, first of all, there were no deep learning libraries like TensorFlow or PyTorch, so it was really hard to go from research to production. You had to be really hardcore to compile Cafe or whatever to implement it. But now it seems like very quickly the bleeding edge language models appear in libraries that regular developers can use.
Okay, so now the last thing for 2020, we'll stop looking at the past and we can use this as a segue to go to 2021. But so there's been a pandemic going on this year. How much of an influence do you think that has had on some of these developments not coming to pass? And is it something that you considered when formulating your predictions for 2021? Like, is there some technologies maybe that are getting more attention now because of the pandemic, and there'll be more development on that side? Or are there areas where there was a lot of work going on until the pandemic came about and then it kind of trailed off? Either one of you can jump in on that.
I think for the most part, this field falls under the bucket of knowledge work. So I'm not sure to what extent it got affected. So maybe people, because of the lack of face-to-face conferences, maybe less collaboration occurred, but I don't detect any anything that could have taken place with or without a pandemic. I don't know. Mikio, what do you think?
Yeah, no, I think probably so many companies were affected, and then, or at some point it wasn't really clear what the effect was going to be, right? So that probably halted like the development a little bit because companies were, but then on the other hand, companies were also taking the time to do bigger like migration projects and things like that, so that they could also adopt new technology. And I think one area where there has now been a lot of focus is around video conferencing, right? So that suddenly became like from a like nice thing to an essential piece of technology, and then you have all these filters and so on, right? So everybody was adding filters and backgrounds, virtual backgrounds, all of that, which I probably wouldn't have happened without the pandemic.
All right. Okay, so moving on to 2021, we'll still follow kind of the same general buckets as we did last year. So if we want to start maybe around the areas of machine learning and AI applications, and let's start with Mikio.
Okay, so 2021. Yeah, I think so this is a bit of an extension of what we already predicted last year, but maybe it's a bit slower now, right? So I think the machine learning operations, that remains a hot topic, how you can, like everything, model management, governance operations, so CI/CD. So machine learning still has to become more, what is the right word? Not professionalized, but there's still like a technology gap from like normal engineering, software engineering, to what you would do with machine learning to put that into production. So I think that's definitely an area where there are also many specialized startups who provide some form of service there, and it's still not really clear like what the best solution is.
The startups provide services to cover the gap. Is that what you mean?
Yes, like services for deploying models. I mean, all the big cloud providers do it, but then there are also a number of independent startups who either use open source projects or have their own stack, so that you can deploy models and model management and all that. Yeah.
And so do you think that the services are what's going to explode, or that the sort of the democratization of ML ops is going to come about and those services won't be necessary?
No, I think the services will then be that what leads to the democratization of that, so that everybody can do that without investing a lot, first having to build up something in-house. I think what's still missing is sort of the convergence that we figure out, okay, what is really the right setup for that. So there are, I think some services are using more like special cases, like simple cases, which they support right now, which are not like what fits for everybody. So I feel like everybody's a bit searching along like how that could look like.
All right, Ben?
Yeah, I mean, I think as Mickey pointed out, so last year maybe we were a bit too wide, so we were talking end to end. And now I think it seems clear that the focus is on people productionizing ML. So that means the operations and governance become important. And as he points out, uh, there are many tools and offerings in this area, but there's no consensus as to what the right processes are. So maybe the tools share a lot of commonality, but inside companies, there's no clear emergent set of practices as of yet. So now related to this is if you're going to deploy your model to production, how do you know it's ready to be deployed? So one of the things that I've been seeing is more emphasis on making sure your model is tested. Tested just as regular software is tested, and also robust. So, for example, in machine learning. Uh, Machine learning models can also be attacked, just like regular software is attacked. So testing for quality and testing for security. So machine learning is kind of a special case in the sense that, I think the New York Times has a famous article where they say, where I think they interviewed a bunch of people in Silicon Valley, and I think they alluded to some of the deep learning engineers being paid the salary of professional athletes, right? So the salary is really high. So you can imagine if you invest that much in your machine learning team and machine learning models, and someone is able to attack your model. So in particular, I think in machine learning, there's two notions: model extraction and model replication. So essentially copying how your model works, right? So imagine if someone can do that, you invested so much in your personnel and your tools, and then they're able to come close to what your model is doing. So there's some more emphasis in making sure your model is ready for deployment. Now, related to that is a topic that we covered in our first webinar, Responsible AI, which is the broad umbrella topic that includes privacy and security, safety and reliability, transparency, fairness. So the idea is related to software quality and software security is maybe before you deploy, you should evaluate metrics beyond accuracy, because traditionally in machine learning research is heavily focused on accuracy of a model. So, but then as we pointed out, all of this is happening at the moment when companies are under pressure to adopt machine learning. So the whole MLOps become faster and more agile in terms of deploying models to production. So how do you balance responsible and ethical AI in a world where you have competition moving faster in ML?
And so, for especially around the security issue, Ben, where are you going to see the biggest implications of that? Like, I'm thinking just like massively distributed on the edge kinds of stuff in IoT or tiny ML, something like that.
Yeah, so it's a bit tricky, right? So because I think if you have a model in the cloud or in a server, then maybe you have ways of uh, of setting up processes and tools around securing your models. But I think IoT and edge devices, and TinyML in particular, Jen, I think TinyML, sometimes the working assumption is it might not even be connected to the internet, because we're talking about devices that are milliwatts, right? So microcontrollers. So yeah, it's going to be harder to do that, because it's not even clear how you update models like that. So
right. Okay, so moving on to the next bucket, kind of still again following what we did last year, we'll take a look at foundational data technologies, and Mikio. What do you think?
Yes. So I think we're really taking the end to end we talked last year about, and then sort of sing it up a little bit. So I think with data technologies, right? So there's still the whole lot about sort of metadata management, customer sort of taking data pipelines, putting all your customer data into one spot, and then companies to sort of focus just on this, so that you have all the sort of really providing the data in a way that you can find it, and that you can do like also stuff which may not even be machine learning yet, right? But it's more also about reporting and BI and all of that, which of course is an important part if you want to go end to end, right? And I think this is like an area where like each year we see like iterative improvement as people are starting to figure out like what is really needed and what best practices are. And I think this will continue into next year. So there's this idea of a lake house. So there are all these metaphors around a data lake. So you have a lake house or a data swamp and other things. So we talked about this. What was that again?
So I think this is actually an exciting area, and I'm part of the crew, mostly helping the founders of Databricks nail down the concept of a lake house. So basically, you have many companies already are familiar with data warehouses. So many companies depend on data warehouses for critical decision making, and then with the rise of big data, you had another set of technologies called the data lake, right? So where you might have a mixture of structured, semi-structured, and unstructured data. So the lakehouse in many ways kind of combines the best of both worlds, right? So you have ACID for data lakes. So you have versioning, but you have the ability to combine everything. Your structured data can be queried using SQL. Your unstructured data can be queried using Python or Scala or whatever programming language you want. So basically, I think this is actually going to be ultimately what companies will migrate towards to simplify their infrastructure. Now, metadata management, actually, it turns out to be one of these things that I started paying attention to in 2015. And now I think this year we're going to really start it take off. Part of it is that now you have a bunch of tech companies that came to the realization that metadata is kind of a fundamental building block upon which they can build many interesting data services. So it turns out that a series of tech companies kind of came to this conclusion at the same time. So there's Data Hub from LinkedIn, Amundsen from Lyft, similar systems from Uber, Netflix, Spotify. So basically, many of these systems focused on building a metadata management platform. And then once you have a metadata management platform, you can build things like a data catalog, data quality solutions, data governance solutions. But one of the things is that in many of these companies, even though they are tech startups, as the company grew, there was an explosion of data systems. So just keeping track of all your data sources and how they're changing and things like that turns out to be quite useful. So for example, if your executives depend on a certain dashboard, if you had a data quality solution, you can tell if the dashboard is going to encounter problems, right? And so it's related to what Mikio mentioned earlier, which is this notion of the customer data platform, which is really an old concept in many ways, but it's an attempt to provide a 360-degree view of your customer. So, but in a world where companies are really using many disparate systems, right? So not just internal systems. Many companies are using software, best of breed software as a service, right? So Salesforce, Mailchimp, all of these things. So how do you tame this data explosion? A couple of other topics in this area that are on the surface somewhat boring, but actually among data engineers, an area of intense activity: data pipelines and data quality. So data pipelines, at least in the last year, I've spoken to many data engineers who are focused on data pipelines, particularly the recognition that data pipelines are fundamental to almost everything that a company does, from ML to BI to any kind of analytics. But then the number of data pipelines is exploding. So how do you inject rigor, software engineering rigor, into building data pipelines? So that's an area that is the subject of many open source projects and startups right now. And related to that is data quality. And so similarly, there's a bunch of software projects and startups. So I think data pipelines and data quality, we're going to have better tools in 2021. And we're actually starting to see some of them come out now towards the end of 2020.
Mikio, what are your thoughts on the tools?
Yes, no, I think so everything I've seen so far in companies is always something custom that they build, right? I mean, so using tools, existing tools, but then the integration of putting it all together, that's usually something that is always specific to the company, and it takes just so much time. So I think there's a real opportunity here to simplify that, right? I think the complexity really comes from, the companies that are now 10 years old, and then there's an old database system they use to get the data, and then another one, and they build it, and just over the years, maybe they clean it up at some point, but it just gets very complicated. And then you have all these things that we talked about, like data pipelines and quality. So if something breaks, what will it affect, right? Or if there's an error in one point in the pipeline, like which dashboards can I trust and so on, which you really cannot do because everything's custom made and put together. So having, right. So, but I think now the patterns are sort of clear, right? So like in all these things, it's always the same, like type of custom infrastructure that has been built. And then I think whenever that's the case, then there's an opportunity to build a product that puts it all together and then creates some value for the customer.
Yeah, because if you look at Jenn, if you look at pipelines, right? So they're pieces of code. So the question that people started asking is how can we bring engineering rigor to the pipelines? But obviously now you have data and code. It's kind of similar to ML that way, right? So in the sense that ML is also the subject of a set of tools around ML ops. But pipelines in general, you have things like, how do you do, Mikio, how do you do unit testing or integration testing on pipelines, right? So people are starting to think this through. So there are now tools for doing some of these. And then when you get to deploying a pipeline, it poses additional challenges, because how do you debug a pipeline that's hitting a distributed computing cluster? So how do you roll out a pipeline? How do you roll back when there's a problem?
Mm-hmm.
How do you do integration testing? Because unlike other software, there's side effects, because your pipeline might be writing to some other systems, right? So there's a lot of challenges that people are starting to think through, but I think the payoff for us is it's going to make it easier for companies to get these under control. So then also, once you deploy, how do you do monitoring and observability, like Mikio alluded to, right? So if a pipeline starts causing problem, how do you do root cause analysis, right? So how do you isolate these things?
Well, and he raised another good point too, that brings the question, like, how big of a hurdle will legacy systems be to some of these ideas that you're presenting?
So I think so the pipelines themselves can be written now using modern programming languages, right? So for example, if many companies use Spark, well, Spark now allows you to use Python or Scala or Java. So you're not limited to SQL. So with modern programming languages now you have access to abstractions like functions and classes. So I don't know if the legacy systems themselves will pose a problem necessarily. I think from that perspective, but I think what they may pose a problem with is when you actually do the entire integration testing of your pipeline, right? So end to end, because I think one way to do that maybe you might have a staging area, and you can test out your pipeline in a staging area. But there are people who are proposing other approaches to doing these things that are, for example, the ones I'm aware of are more specific to Spark, for example. But yeah, so the problem with the data applications, which includes data pipelines and ML, is whenever you want to really test end to end, then you have side effects, right, Mikio?
Yeah, it's yeah, usually sort of it's organized, everything sort of it works because it has to, process quite a lot of data per day. And then just thinking you have to set up like a second one or even parts of that just for testing, right? If there's no tooling support for that, then it's really a lot of manual work. So yeah.
All right. Well, so somewhat related to what we've been talking about so far.
One last topic here, Jen, which is in BI. The notion of, so the people talk about auto ML. So I'm proposing a new term, auto BI.
All right.
Which is basically actually. So it's actually not a new notion, Mikio. I don't know if you've encountered this, but in many companies, you can imagine you're a business person. Your KPI might be say churn, right? So something like that, churn. But then, so you can go into Tableau and slice and dice 200, 300 dimensions to try to figure out what's going on. But now what new startups are doing is basically applying some ML so that the ML wades through all of the different potential drivers of your KPI and draws you the right charts and conclusions. So basically it optimizes or speeds up what people are referring to as time to insight, right? So instead of you manually going through, because I mean, to be honest, Jen, these visualization tools were revolutionary. The Tableaus of the world, it gave analysts the ability to do a lot of visual analysis. But how do you do that when you have a lot of data and a lot of potential metrics, right? So
it's also easy to drown in all these metrics, right? So I think, and there's always the case if something goes wrong, then somebody has to do a drill down, and that's still very manual. But in principle, as you say, so going through all the different possibilities, looking for anomalies and so on. This is something where you could use.
And it's not that hard, right, to do.
Yeah.
Yeah.
It's definitely easier than looking at these things as a human.
Yeah.
So are there startups working in this area already?
Yeah. There's a few startups. There's more to come. Yeah.
So, but auto BI, I wasn't aware that you just invented this. So this will definitely go on our list for next year's follow-up.
Oh well, there's already startups. I'm aware of more that just got funded.
So you're cheating, is what you're saying.
Well, I think I've always wanted this tool, Mikio. I don't know if you've always wanted a tool like this, which is basically, I don't want to figure out what chart to draw, just draw me the right chart.
Yes.
Right. So here's a data warehouse or data system. Right. So for today, because I think traditionally, Jenn, is you have a dashboard. The dashboard has the same charts every day, and so then the decision maker at some point maybe kind of, well, this is like watching paint dry, right? So nothing changes really.
Yeah.
So but then there might be things that are actually changing that are important, but if you're tied to this one view, then you won't see it, right? So
Mikio, this is something you definitely want to use.
Yeah, no, it's I think like I've often seen, like, or what I've seen is like you have KPIs and then somebody came up with a driver tree, right? And they say this is going down because, and we need to work on this for that. But of course, so they are not pretty big. So you maybe have like 6 or 8 different quantities which you relate to what you're looking at. And that reminds me a little bit like when you do a decision tree yourself or when you have the machine do it, right? So the machine can go, I don't know, 20, 30 levels deep. But as a human, you can just do smaller things. So I think there's definitely, I mean, depending on the complexity of your business, there's some potential to find stuff that you would never find otherwise. Yeah.
Excellent. Well, we look forward to reviewing how that prediction turns out, Ben. So our next area of interest is cloud computing. Mikio, you want to start with that one?
Yes. So do you want to start, Ben? I'm always starting.
Yeah.
New topics.
So cloud computing. So 2 things. So I think people have heard of serverless. So what serverless did was basically abstract away infrastructure so developers can just focus on writing programs. Because for those who don't use cloud computing technologies, there's still a lot of manual management that you have to do and be aware of if you're not doing it on a day-to-day basis. And then secondly, serverless also provided finer grained increments for billing, so you could be billed basically sub-second. So I think the most popular serverless technologies are what people called function as a service. And so I think what the aspirational thing here is that how can we take serverless and generalize it a little more so that it can support more interesting workloads like machine learning or data processing. And so that's one of the areas I'm paying attention to, mostly because I'm associated with the Ray project, because the Ray seems to be an interesting substrate that can let you do applications that have state, so stateful applications like machine learning and data processing, and still keep to that serverless model. Maybe not to the millisecond level, but maybe in the few second level, right? So serverless, more general. I think that'll be an interesting trend. And then the second thing is mostly born out of a post I wrote earlier this year where I waded through a bunch of surveys to try to understand if companies are using multiple cloud providers. And it turns out a vast majority of companies are actually multi-cloud, where multi-cloud is defined to be using more than one cloud provider. Could be more than one public cloud, could be a public cloud and a private cloud. But I think for the most part, it's no surprise actually that most companies are using more than one cloud, because one, if you stick to one cloud, then more likely you'll be locked in, and I think there's a lot of companies who want flexibility. Secondly, you can probably save costs if you use multiple clouds, because you can optimize obviously your cost structure because you have more than one choice, right? And then there are also notions around compliance, because basically with GDPR and these privacy regulations, you might need to locate your data in certain countries. So you might be forced to use more than one cloud that way. But with that said, I think that so set aside the reasons why people are going multi-cloud. I think the first thing I want the listeners to know is that when I say many companies are going multi-cloud, I don't think I saw a survey where the number was less than 80%, right? So most companies are definitely using more than one cloud provider. So to me, then I started looking at what does that mean in terms of tools. Well, now I'm going to coin another term here, Mikio.
All right.
All right.
So
So I would say, so there's the traditional software as a service, right? So if you're a company like, let's say Snowflake, right? So you can say, well, I'm only going to support AWS. But then you realize that actually some of your customers, potential customers, are not on AWS. So I would say then traditional software as a service companies have recognized this. So most of them are actually available as applications on all the major cloud providers, right? So that, and then the second class of things that I'm looking at is what now this is the new term, drum roll, right? So it's what I would call multi-cloud native applications. Huh? So the first example there, I would say, is one good example there is Bigquery Omni. So with Bigquery Omni, I have the Bigquery user interface, right, for doing queries. But some of my data might be in Google, some of my data might be in AWS. I can still run a query involving both. So basically, applications that let you basically choose your data and then run your query based on what the data is. Now there's also applications like Anyscale, which basically you say, I'm going to write a machine learning training model, and then okay, now I'm ready to train it, and then you can pick, okay, I want to do this training on this cloud platform or this cloud platform or this cloud platform. So you write your code first and then choose your cloud later. And then I think ultimately what we'll see is basically platforms, essentially kind of like Anyscale in the sense that you can write your code and choose your cloud later. So the cloud is completely, in many ways, commodified. And you can imagine also writing on top of a platform like Anyscale. If you're like a computer vision company, then you just write it on top of Anyscale, and then if your customer lives in this cloud platform, it'll work. If it lives it on this cloud platform, it'll work. So it'll make it easier for you as the creator of the software as a service to support multiple clouds at once. So I think right now, I think by far, obviously, the dominant thing is I'm a software as a service. I'll make sure I'm available on all the clouds. But I think over time, maybe, as Bigquery Omni is hinting at, maybe your relationship, Mikio, is with Bigquery Omni, and then the clouds are just storage and compute for you, right? So,
what do you think, Mikio?
Yeah, so I think so regarding serverless, I also think it's a great opportunity here because, so for example, if you look at things like AWS SageMaker or so most of them are currently using just Docker images if you want to bundle your model, but which are pretty so let's say heavyweight, right? So there's like a standardized way you have to put your model in, and then you can sort of deploy it wherever you want. But I think especially data scientists, so most of them, they would rather really just focus on their Python code and not think about all this infrastructure. So, and then if it's essentially your model is just a function and you could deploy that would be, I think, very helpful for most, right? And then you really don't have to think about it. And I think serverless itself is really quite interesting for many companies because it makes everything so much easier. So you don't have to maintain images and patch them or reboot them or whatever, right? So every time you just point to the function and then you let it execute.
But now, Mikio, now imagines serverless with state, right?
Yeah. Okay. That's the.
Yeah. So that would be interesting.
That's the yes.
Yeah.
So like the holy grail of serverless. And then I think with the cloud, so I think we talked about this before, and then we had also this notion of being accidentally multi-cloud, right? So
right.
Some companies, so many companies, like the companies I worked at, usually they use Google Analytics, and then you have just some part of your data is just in Google, but then let's say everything is on AWS, and you always have this problem of having to transfer data and so on.
I think some people call that kind of the shadow IT, where if decision making is decentralized, your group may choose one cloud platform, my group may choose another cloud platform, and before we know it, we're multi-cloud, right?
Yeah, right. And then I think the interesting thing is, right, so normally or like it's like if you're developing your own stack and having that like your own software to be multi-cloud, that's usually a huge investment, right? And you can ask whether it's really worth it, or you say, oh, just be staying just on AWS or just on Google. But now, because there are all these service providers, right, and they are becoming multi-cloud, or as you said, multi-cloud native, because they want to offer their services on all the clouds. Now suddenly they are building a bridge for people to be multi-cloud. So I think so before we had that, right, it was like, okay, now we have our data on 2 different cloud platforms. This is not good, right? Now we have to maintain it and so on. But now we have more and more services who just spanning that, and then it gets much easier to do that. And it's not, so that's like I think an interesting side effect of all these companies just trying to make their products available on all the different platforms.
And this is obviously not a trend necessarily that the cloud platforms like, because they want to,
yes,
they want the customers on their cloud, number one, and then using their services if possible. But if the customers now start thinking of them as just abstract storage and compute, and then their relationship is with some other company that cuts across the different clouds, that's not good. But with that said, we still want Amazon, Google, and Azure to sponsor us on this podcast at some point.
Of course.
All right. Well, let's close our prediction conversation for this year with the most exciting, sexy topic of emerging AI trends. Who wants to start?
So I think you've come to the wrong people here in terms of because we're going to throw some cold water on the whole AI thing a little bit. So one of the things I'm paying attention to is kind of how far people can carry deep learning. And actually, recently I had someone from MIT, a researcher who was part of a paper that laid out kind of the computational limits of deep learning. And it's so basically the idea here is they looked at certain areas, let's say computer vision, machine translation, right? So Mikio, these are areas where there's years of research and progress. So they could model basically, okay, so in order for us to lower this computer vision benchmark by this much percent, the error, how much is it going to cost? And so it was amazing to see them do this for a variety of tasks, so ranging from computer vision to machine translation. So for example, they looked at ImageNet, and then they said, okay, so they had the notion of, well, what if we can lower the error by this much or this much? So they had certain levels of improvement. But even the first level, right? So not the most accurate of improvement, they project the cost will be $100 billion.
Yes.
So clearly there's limits to what we can do by just kind of doing what we're doing now. So So it's a cause for concern, but maybe it's also a cause for hope, and that maybe that means that people will start exploring other ideas or hybrids, or or just incorporate things like domain knowledge. So you're
Yeah.
starting and coincidentally, I'm starting to see more interest in knowledge graphs and knowledge bases again.
Mm.
But and then there's certain areas, even in robotics, where people are realizing we might be able to incorporate ideas from control theory, uh, to so that we can make faster progress with less data, for example.
Yeah.
But clearly, I think if you just go throw more and more compute, at some point you're either going to run out of compute, run out of money, or global warming, right? So
Yeah, I think so there has been already, so even before the study, so if you just looked at the, I think in all these NLP papers, they were actually talking about or they were bragging with the amount of time it took and the number of compute units and so on. And then people made like back of the envelope calculations. And it's just, I don't know, 70,000, or like the electricity bill for that was like a small town or so, just to get like an additional 5% or so performance out of it. Yeah.
yeah,
So I
and then
think it's
and then some of those papers, I think it might have been the one from OpenAI, one of the GPT papers, where I think they may have realized that okay, so we have to fix this, but no, we've kind of in the middle of training. It's going to cost too much to start
okay.
over.
Yeah. can't afford it. Yes.
Yeah.
Yeah, I mean, in a way, right? I think so. I've been in research also for more than 10 years, and it's always like this. So somebody finds a new idea, and then everybody's going in to exploit it, and maybe we're coming to the end of that with deep learning, and then so we probably have to find something new. But the good thing is now that we have all this compute power around, right? So yeah. Let's see. I mean, that's something that's really, really hard to predict. But I think probably there will be like what it exactly will be. But I agree that that it can't go on much further than this in
So it's
terms
not
of.
necessarily throwing cold water. It's opening doors of opportunity. It's a very exciting area still.
Yes, you just don't know where the doors are or where they lead. But yes.
Yeah, and actually, I think the same researcher from MIT that I was talking to, he said that actually, since their paper came out, he has been approached by people who are, let's say, not in the deep learning school of ML, and they were saying that now even they are starting to get more interest from other parties, because just because I think that as Mikio said, we're probably now in year 6 or 7 of deep learning, right? So
Yeah.
All right. So Mikio?
Yes. So now we're coming back to the low energy AI hardware. Yeah, I think so. It's an interesting factor. It also took me a little bit to understand. So there were at some point there were popping up all these things like you can do ML on a chip or ML on a Raspberry Pi, and I wasn't really understanding what it is. But then I understood that they make this possible by focusing on application. So not training, but applications. So usually it's like lower. It's like integer arithmetic, or in general lower precision, so it wouldn't be enough if you want to train, because then the gradient become too noisy. But it's really, so if you have a model and then you want to bring it to the customer, or I don't know, on the smartphone or whatever, then so they put a lot of research into this, so all the hardware and chip designers to make that happen. And now, as I already said, so Apple's M1 processor has it. I mean, I think they have been having it for quite a while.
so Mikio, these are inference
Yes, for
only.
inference. Yes, yeah, inference, or just so applying the model, right? And I think there's so one thing is, I think already, so it's still the case that if you do speech to text, so if you talk to your phone, it gets sent to the cloud. And I recently saw somebody who compared like the speed of text transcription for Apple devices and for Android devices, right? And Google is just like twice as fast, and that makes such a huge difference. So if you now do the additional step and do that completely on the device, I think it will really open up a whole like a new level of usage of that technology, right? So it already got very good. If I remember, like, I don't know, 15 years ago, it was more like a joke if you tried to talk to a computer, but now they got really good at that. And now imagine that you have this, but there's no perceivable lag anymore, right? It's not like you say something, hey Siri, and then 2 seconds later it recognizes what you say. And then that was also interesting. So NVIDIA did this demo of a new development kit, I think they did, and what they did is they applied these guns to video compression, right? So this comes back to the video conferencing stuff I said earlier. So with guns, you can have these very realistic renderings of people, and they used it, for example, to exchange faces, but you could just use your own face, and then use that for video conferencing, and then lower the amount of data you have to transmit a lot, right? And then so if you combine this with, I don't know exactly whether you can already do it with the chips we have nowadays, but in principle, that could really lead to like AI
So
powered
application is video compression, which would manifest itself as video conferencing,
yes,
among other things.
Yeah. Oh, I mean, I think you could also do stuff like, so if you, I don't know, if you want to get a coffee or something, you just push a button and then your face is still there and still does movements as if you're listening, but actually it's all AI generated, and then you can come back and things like that. So
I see.
Yeah, so it's I think that's really just the beginning.
Taking deep fakes to a different application domain. No?
Basically, I mean, doing something useful with that. I mean,
right. So one question about the speech to text, because before the pandemic, it might have been late last year, I was in a loud coffee shop with a friend of mine in San Francisco, and he was raving about the Google Pixel phone. And then he proceeded to give me the following demo. He put it on airplane mode, and then we kept talking. So airplane mode, so it was completely disconnected, right, from the internet.
Yeah.
We kept talking. It was just transcribing perfect in a loud coffee shop in real time. And then he did the same thing with Siri, with Apple. It was transcribing, maybe some more error, but also noticeable lag. So it seems like the speech to text, at least on the Pixel phone, doesn't have to be connected to the cloud.
Oh, okay. Yeah, maybe I wasn't aware of that.
Yeah.
But then I think you can still, like, if you now can run like full deep learning models on that could, I think, still lead to more improvement. I don't know how they did it before, but yeah.
Yeah. So for me, going back to natural language application. So we talked about earlier how the speed between research to getting it into the hands of developers has really accelerated. So I think that opens up more and more applications potentially for that we'll see in the future. So that may surprise us, right? So because I think that natural language is obviously widely applicable. A lot of companies have it, and now we're lowering the barriers, right? So in terms of usability, basically, I mean, you can pip install all of these libraries and you're off to the races. It's really a question of how well documented they are and how inventive you are at this point.
Well, and so also related to the deep fakes that you were talking about a moment ago, we're in an age of disinformation right now. What about instead of using the AI to create the deep fake, what about using AI to identify those sorts of things or disinformation?
Yeah, I think that so there are many ways that people are using machine learning to identify fake media, but I think they're also recognizing there's two related tasks here. One, you have to identify whether or not it's fake, but you have actually no control, because sometimes it may not be up to you, right? So it may actually end up being in a social network. But then the other problem then becomes, how do you slow down the spread of the fake once it's out there? Which actually, I was talking to Mikio about this last week. I think part of it is that maybe in some domains, maybe this is it. We may need to revisit whether or not, to what extent should we use machine learning, because maybe because many of the platforms that spread fake information use clever algorithms, mostly to optimize the time people spend on their site. What if we start optimizing for other things, or maybe we just display things in reverse chronological order and forget about the models? But then, as I was preparing for this today, I just came across a New York Times article which basically seems to suggest that actually a major, to be unnamed, not to be named social network turns out to have a switch to identify quality of source, right? So then if they use this signal, turns out they can actually slow down the spread of fake information. And they've had this all along, but then so maybe there is a role for machine learning in terms of slowing down the spread of fake media. Which actually, I was talking to a graduate student who wrote a paper on fake media, and this is one of the main signals they use, is the veracity or quality of the source, right? So,
Mikio, what do you think?
Yeah, this is a very difficult, well, let's say it's a very complex topic, I think, right? So which is so part is what is algorithmically possible, but then also in general, so how these companies are set up, what are their incentives, and what they want to do about stuff. So let's say I think with AI, it's always, so it's potentially technology with which you can do like a lot of crazy stuff and a lot of harm also if you really want to. So it's always, I think it's always a question what we do with it.
responsible AI.
Responsible AI, yes, of course. Yes. Yeah, and I think so I always used to say sort of the biggest risk comes from us trusting AI too much, you know? So if you let AI actually make real world decisions, I think for like autonomous driving and things like that. So there has been, like if you look at some of these accidents, it's very clear that these cars have very limited understanding of what they're actually looking at, right? So mistaking a truck for a sign and stuff like that, and still we let them sort of drive around with real world consequences, and then that sort of applies to everything. So yeah, I should always be aware that there are some limits, and even we call it intelligent, maybe sometimes it's not really that intelligent. Yeah, but yes.
All right. Well, any last minute thoughts?
No, I think for me, I mean, as much as we all pay attention to AI and machine learning, I think don't fall asleep on some of the things we covered in this conversation around the foundational data technologies, because they may actually, at a company level, they may actually be more impactful.
We'll be taking bets on the auto BI prediction.
Oh yeah, and multi-cloud native.
Multi-cloud native, yes. All right. Well, with that, thank you both very much. We'll see you here next year to review this.
Yes.
Yes.
Very good.
Thank you.
Thanks for having me.